Welcome back to Diabetics for Diabetics, the go-to place for all things current diabetes research, as well as lifestyle and healing modalities, where throwing around medical jargon and piggybacking off of our current medical narrative is not enough. I'm your host, Bowie. I've had type 1 diabetes for over 20 years, and today we're diving into the scientific research to extract tips, tricks, and explanations that will help us better manage the diabetic state. In today's literature review, we are going to be reviewing a paper titled Iron and Diabetes Risk. It was published in Cell Metabolism in 2013, and it is one of my favorite papers in delving into the foundations of iron homeostasis in the body, and then branching into all of the well-documented cases of the relationship between iron mismanagement and altered glucose metabolism. If you are new to the iron and diabetes relationship, I recommend you go back and check out my podcast, Diabetics for Diabetics Radio, where I divulge a lot of the information talking about how connected iron and diabetes is. However, if you just want to check this paper out as well, this has served as such a launching pad for me in terms of branching out into different areas of iron metabolism and dysregulation, as well as how that affects diabetes from a glucose metabolism standpoint, from an inflammation standpoint as well. So let's take some time to break down the paper.
So here we are, Iron and Diabetes Risk, Cell Metabolism 2013. Now, like I mentioned before, this paper does a great job of introducing iron metabolism in a healthy state to give you a good foundational understanding of what we're departing from when we go into states of disease like diabetes. And we'll just do a brief summary of some of the information here, but I want to bring your attention to this point in particular. So, most iron in mammalian organisms is recycled at a rate of 20 to 25 milligrams per day. That is how much is being reused by our body. That 20 to 25 milligrams was already in our body. We didn't need to take it in. And this is being done when old blood cells are being recycled, which is basically what's being said here. Macrophages, endocytose, senescent erythrocytes. Senescent erythrocytes just means old blood cells, and they're being absorbed and recycled. That's essentially all that means. So roughly 5 to 10% of that amount per day of that 20 to 25 milligrams is taken up through the intestine. That's what's being absorbed to make up for what isn't being recycled and is being discreted or excreted. So our body is incredibly efficient at recycling the iron that has been used and is being dumped from old blood cells. Very, very good at it. And whatever's left, that 5 to 10%, very, very little amount, is being absorbed through the small intestine from the food that we're eating. Of particular importance here, mammals do not have the capacity to secrete excess iron in a regulated fashion. In equilibrium, losses through sloughing of the intestinal epithelium, so where our small intestine is absorbing the iron, those cells are progressively being pushed out and recycled the same way that any other cell type is being pushed out. The old is going out, the new is being built from within. So we're pushing out intestinal cells that hold iron, and they're just kind of being recycled and excreted via our feces. Death of other cells. So every cell in the body is using iron to some degree. So when any cell dies, that iron is being released into circulation and being properly disposed of. And this says biliary excretion balance. Biliary excretion is just what our bile is absorbing. So bile is made by the liver and is a digestive aid. So this is just how our body is packaging the food that we're taking in and getting rid of properly. Okay, so Sloughing the intestinal epithelium, that means losing intestinal cells that are taking iron in, right? That's a way that we're getting rid of iron. Death of any cell that already has iron in it, and then proper digestion of things containing iron. Now, this is what balances intestinal uptake. But when uptake exceeds loss, we're taking in more than we're able to get rid of. Excess iron is sequestered intracellularly. Sequestered means pushed in or taken in intracellular into cells. And the paper goes on to outline and diagram exactly what's going on with all the specific enzymes as well. So from the gut lumen, we're eating things containing iron. That iron reacts with specific proteins, which allows for it to enter circulation, where the liver is able to read that, release the proteins necessary to properly move and circulate iron around, where it is headed to its target cell, whatever cell it may be going to do what it needs to do. That could be blood cells. It could be any cell, essentially, to help catalyze cellular respiration. Now, for the purposes of this video, this isn't meant to get into the nitty-gritty, dirty specifics of every aspect of iron metabolism, but the paper brings up a lot of good points surrounding our current standards of iron absorption and proper iron levels. We'll go to this paragraph here. So an important fact to consider in evaluating the effects of iron on metabolism is the very wide range of what we consider, quote unquote, normal serum ferritin in humans, which is 30 to 300 nanograms per milliliter in men, and then 15 to 200 nanograms per milliliter in women. This is a huge, huge range, and it goes on to say the levels of very few human blood constituents have such a tenfold normal variation, right? So almost nothing else in the human body has a standard or an acceptable value of a particular nutrient that is so broad, 30 to 300 or 15 to 200 for women. And the paper acknowledges that just because it's called normal, quote unquote normal, does not preclude it from conferring negative health risks of which we aren't completely aware of.
So as you can see, iron absorption is tightly regulated by our digestive system as well as our liver. Both have an intimate relationship with how our iron is absorbed into the body and how it is properly distributed. It's also important to note how tightly connected iron is with inflammation in times when it's not properly held.
So now let's talk about how iron dysregulation, if iron is not going to the proper places, how that can lead to inflammatory measures that are directly linked or correlated with the development of diabetes. And it's mentioned here, the first and clearest evidence for a relation between iron and human diabetes came from clinical observations of individuals with pathologic iron overload. I've mentioned this in previous episodes of Diabetics for Diabetics Radio, where there is a huge percentage of people diagnosed with hereditary hemochromatosis that are diabetic. At least half of people with iron overload develop either type 1 or type 2 diabetes. And in each paragraph of this paper, they're talking about the different types of iron overload. Like I mentioned before, hereditary hemochromatosis. This is the one that is most covered in the literature. This is a genetic inclination to an overstorage of iron. But there are additional ones, things like beta thalassemia, which has to do with improper blood recycling. And this group of people is reliant on blood transfusions. And anytime you're getting a blood transfusion, you're getting huge influxes of iron, which leads to these inflammatory conditions like diabetes. There are also things in non-pathologic states like dietary induced iron overload or secondary iron overload. This is an interesting component of iron load and diabetes. This references a study where they quantify the risk of developing diabetes based on different metrics of iron. So let's take a look at the graph here. So pregnant women, gestational diabetes is incredibly not popular. It happens a lot, more and more these days than typical. So this is just mentioning that pregnant women in the highest quintile of iron intake are almost twice as likely to develop diabetes. Another study found that the same metric, right, in those pregnant women with the highest decile, so even, instead of a quarter, it's the highest tenth of women with iron intake have a 3 times as likely chance of developing diabetes. Women with high ferritin, 4 times as likely. Men with high ferritin, 5 times as likely to develop diabetes. And then women with the high-end range of ferritin versus the low-end range of ferritin, right? Remember the acceptable values? It's 30 to 300 for men, 15 to 200 for women. This is comparing the upper range of that level and the lower range of that level for women. A 4-time difference in the likelihood of developing diabetes.
So as you can see, regardless of the source of the iron mismanagement, whether it be hereditary hemochromatosis, transfusional iron overload, secondary iron overload, dietary iron overload, all mismanagement of iron is impacting glucose management, specifically in the diabetic state.
So with all of this talk of iron and diabetes, the fact that our body is incredibly efficient at taking in iron, and because of that efficiency is not very good at offloading iron, combined with the fact that with our modern diet and all of the compounding medical issues that we're dealing with, our iron retention is increasing. What are some things that we can do to stop this iron influx? And this section here, the reduction of iron as a treatment for diabetes, goes through a number of studies in both animals and humans looking at the use of phlebotomy, offloading large amounts of blood in order to decrease iron levels and improve beta cell regeneration as well as insulin sensitivity. And while there are studies showing humans donating blood can help them better manage their glucose, it's worth noting that somewhat surprisingly, human data on the effects of iron depletion in common type 2 diabetes are scant. But the studies that do go into the effects on glucose metabolism of donating blood find a lot of really good things. Now, blood donors exhibit increased insulin sensitivity and secretion, although there may be selection bias in the fact that usually only healthy people are electing to donate blood, but they are seeing improvements in insulin sensitivity, insulin secretion, and overall glycemia. And the effects of phlebotomy supersede just the insulin markers and glycemia indexes for these people. It goes into hypertriglyceridemia, right? So like if you have hyperlipidemia, at a risk of cardiovascular disease, vascular reactivity, and then markers of non-alcoholic steatohepatitis, which is just non-alcoholic fatty liver disease. All of these things are decreasing with donating blood and offloading these large amounts of iron.
So it's interesting to see that even though there may be many more additional factors that complicate the development of diabetes aside from iron, it's very interesting to see that the reduction of iron through phlebotomy has had a positive impact on glucose metabolism and fasting blood sugars.
And this paper goes into even more detail after the fact, talking about the exact cellular mechanisms of how iron influences glucose metabolism. It talks about the Fenton reaction and the creation of reactive oxygen species, the basic currency of inflammation in the body, and how iron is a major source of that. It talks about hypoxia-inducible factors, things having to do with a lack of physical fitness, a lack of physical activity in different populations. It goes on into AMP-activated protein kinase, which also has to do with physical activity and our body's ability to properly utilize energy with and without oxygen, with glucose, without glucose. So there are a ton of different elements that this paper goes into that is all worth getting to know when it comes to learning more about the diabetic state.
This paper is incredibly thorough in walking through each of the iron metabolism itself, the disorders that lead to the mismanagement of iron, and then all of the downstream effects of iron and how they correlate with the development of diabetes. Now, for the purposes of this video, this is really just an introduction to all of the things that this paper has to offer. There is going to be multiple parts looking at all of the topics covered by this one paper. So that's it for this video. As you can see, there is such a well-documented connection between iron management and glucose metabolism, and diving deeper into those subjects within it, whether it be the inflammation caused by it or the nutrients needed to rebalance the iron, there is so much purpose here in terms of getting to the bottom of the diabetic connections. So if you found any of this helpful, go ahead and subscribe to the channel. Follow me on TikTok. I'll have all the links in the description for that. But we are covering everything related to mineral deficiencies, hormonal imbalances, and lifestyle changes that you can make to improve your health as someone with diabetes.